Hi, we are going to do the Unit 7 and 8 test review. Again, I would suggest you do it first and then come back and listen to what I say, or if you get stuck, then let me help you get through or start it before you watch what I do completely. Number 1 says, in the figure, triangle FGH is similar to triangle KLM, and to find LM. So I would set up a proportion here. I would say that this side 32 corresponds to 24, and then I need to come back to the FGH triangle, so I'm going to put 20 on top, over x, and then all you have to do is cross multiply and divide. So 24 times 20, because I'm going to do this part first, is 480, and then divide that by 32, and that gives me x equals 15. So LM would be 15 centimeters. Okay, if I am looking at the scale factor from triangle KLM to triangle FGH, let me look at that here. That is saying that this is your old and you are going to your new. So this is the new side and this is the old side. So I want to do a scale factor that says new over old. So I just pick any side that I know. I would say I'm going to pick this 32 over the side that corresponds with it, which was 24, and then I'm just simplifying. So if I simplify 32 over 24, 4 goes into both of these. Oh, I could even go better than that. Let's say 8 goes into both of these, which would give me 4, and if I divide this one by 8, I would get 3. So my scale factor is 4 over 3. So my rule when I use a scale factor is a dilation, which means I just multiply. So it would be 4/3 x, 4/3 y. Okay? Number 2. Point A, -2, -10, is reflected across the the x-axis. Write the coordinates of A prime. So I know if something is reflected across the x-axis that x stays the same and I do the opposite of y. So if I have -2, that means my -2 stays the same. The opposite of -10 is +10. So that would be D. Okay. Number 3 says quadrilateral ABCD plotted on the grid below. I'm going to scoot this so we can see everything. On the graph, draw the image of the quadrilateral ABCD after a counterclockwise rotation of 270 degrees. So the first thing I would suggest doing is to write your rules. So you know if you're going counterclockwise, you're going this direction. So this would be your 90 degrees counterclockwise. This is your 180 degrees, and then this would be your 270 degrees counterclockwise. If I'm writing a rule for that, remember this is where we start. So this is your XY. Remember this one stays XY. We just change the sign on both because if I go to the left, that's negative, and if I go down, that's negative. When I go 90 degrees counterclockwise, this becomes YX. My first numbers are negative, so it's going to be opposite of YX. And then this one is going to be YX2, but this is going to be a positive and then a negative. So it's going to be Y opposite of X. What I would suggest is the first thing you do is write down your coordinates for A, B, C, and D. So let me zoom out just a little bit so we can see this. So for A is at 5, 6. B is at 10, 6. C is at 8, 1. And D is at 3, 1. So my rule when I looked at a 270 degrees counterclockwise was where I went from y opposite x. So that means that when I am looking to rotate that, then A prime, we're going to flip the numbers and change the sign on the second one. So that's going to be 6, negative 5. B prime, flip the numbers and change the sign on the second one. So 6, negative 10. C prime, flip the numbers, change the sign on the second one. So 1, negative 8. And D prime would become 1, negative 3. And then you're just going to go graph those. So if I go over 6 and down 1, 2, 3, 4, 5, that's going to be A prime. 6, negative 10, should be about right there. B prime. 1, negative 8. C prime. And 1, negative 3. D prime. And then you just connect your dots. Your figure should have remained the same. It should have just rotated 270 degrees counterclockwise. Number 4. What would be the coordinates for a dilation of a scale factor of 2/5? So anytime you have a dilation, all you're doing is multiplying it by the scale factor. So we're going to say 2/5 x, 2/5 y. Number 5, a trapezoid is located on a coordinate plane. If the ordered pairs A, B represent a point of this trapezoid, write the algebraic representation that describes the effect of translating. So remember, when we translate, we just add or subtract 7 units down. So that's your y, and 4 units right. So that's your x. So when I do this, if I go right, I'm going to add 4. And if I went down on my y-axis, I'm going to say y minus 7. Okay. Number 6 talks about list the transformations that preserve congruence. So we want to know what transformations are congruent and which ones are not. So we've talked about this over and over in class, and we said that translations are always congruent. Reflections are always congruent. Rotations are always congruent because all we're doing is moving those. But that dilations are not congruent unless they have a scale factor of 1 because they get bigger or smaller.